In a movement with a rotation, we have to be clear what it means delta theta. Delta theta means the change in the angle. So you go from here to here in a rotation, and you change the angle from theta 1 to theta 2. So the change in the angle is here, delta theta. So that happened in a rotation. So delta theta is theta 2 minus theta 1. The second thing that we have to be clear is that when there is a rotation, there is a change in the angle, delta theta, and the body rotates through an axis. So this is the axis. If the rotation takes place in the xy plane, this will be the rotation in the xy plane, and the axis of rotation will be like this, and every point around the axis will make a rotation, and the path of every point will be a circle. Every point will be a circle in a way that if you have a body like this, let's say this is the body, and this is the axis of rotation, this point will make a circular movement around the body, around the axis. So this is the second thing that you have to know, is that delta S and R, there is a relation here. Delta theta is always measuring radians. And the relation is that delta S, the length of the arc of the rotation is R by delta theta, always. And delta theta is measured in radians. And what is 1 radian? 1 radian is the angle that sustains an arc of 1 meter when the radius is 1 meter. Delta S is 1 meter when the radius is 1 meter and the angle is 1 radian. So this is the other thing that you have to understand, that what it says, this equation delta S equal R by delta T, what it says that 2 pi R is the length of the circle. The other thing is that change in the angle, theta 2 minus theta 1, delta theta, divided by delta t. This equation is very similar as the velocity, the linear velocity, which is the change in position per unit of time, but here is angular velocity. It's not the change in position, it's the change in the angle, delta theta divided by delta t. So omega, you see this theta. This theta is because we consider omega a vector, and the vector have a component in the theta direction. The theta direction is the direction that is perpendicular to the plane xy where the rotation takes place. So omega is here. This is on the vector omega. The vector omega is on the theta axis, and this is omega. And the magnitude of this vector is the magnitude of delta theta divided by delta t. Okay, so here you have the vector omega. How to find the vector omega? You use the right-hand rule. And if you have a rotation like this one, that is a counterclockwise rotation, you generate a vector omega that have the magnitude of the angle that is being rotated divided by the time that is take place, and the vector have this magnitude, the angle per unit of time, and the direction is the direction perpendicular to the plane of rotation. So in this case, it's in this direction. If you rotate instead of counterclockwise, clockwise, like this one, omega will go down. So this is the plane xy, this is omega theta, is positive in this direction, and is negative in this direction. So The other thing that we are going to define is the angular acceleration is very similar as the acceleration that is the change in velocity, but the angular acceleration is the change in angular velocity per unit of time. So it's omega final minus omega initial divided by delta t. And if you see here, there is a theta here because we are supposing in this definition that the rotation takes place on the plane xy. So the omega is on the theta direction, so it's omega final in the c direction minus omega initial in the c direction. So omega final minus omega initial per unit of time is the angular acceleration. And the instantaneous angular acceleration is the average acceleration, but when delta t is very, very small. We see the same idea with the instantaneous velocity. So let's see this picture, for example. This picture, it has a wheel that is rotating with omega 1z at certain time t1, and at certain time t2, omega 2c is the angular velocity of the wheel is bigger. So what happened is that there is an acceleration, and the reason why is an acceleration is that on the c-axis you have omega 1 at t equal t1, and t equal t2 you have omega 2 bigger, so you have a change in omega. And the change in omega is this one. This is the change in omega. So when this happens, you say that you have acceleration. And the acceleration is delta omega divided by delta t. And what is the direction of the acceleration? In the direction of delta omega. So alpha is also a vector. And that's all to start studying this. Well, here is the picture. Here is the picture. Let's go to see the picture. Let's go, if I can make it bigger. Okay, here is the picture. You see omega, the body is rotating in the counterclockwise direction. This is omega initial, and omega final should be some kind of vector that should be like this. Should be like this if delta t is equal 1. Omega final is some vector, so alpha is delta omega divided by delta t. If I don't know, alpha and omega have the same direction. Yes, it's true. If omega is increasing, alpha and omega have the same direction. On here, alpha have opposite direction as omega, because omega initial is like this and omega final is like this. So delta omega is going down. So in this case, omega and alpha have different directions. Okay? The alpha is omega final. Let's say that omega final is like this. So alpha will be omega final minus omega initial. So this vector minus this vector minus this vector, but divided by delta t is not exactly alpha, is not this one, okay? Because we have to divide by delta t. Okay, so that's all from